Good morning and very welcome to this, our third Space Hub Lund session. Today we are airing this session from the Black Box at Stenkrossen. That's the stone grinder in Lund. My name is Anders Bengtsson, and sitting not so close but next to me, Per Ahlstedt. How are you doing today?
Fine.
Oh.
Good morning.
Good morning. Oh. So, since the inauguration session of Space Hub Lund on November 20th last year, we had a most interesting journey with so many engaged people contributing with knowledge, ideas, initiatives, efforts, and not least their pure interest in shared vision of utilizing space technology on Earth. We have had a great company from the start and continued support from Swedish National Space Agency, European Space Agency, ESA Sweden, ID and Science Park, our local innovation community, academy, local corporations, plus politicians and fellow colleagues in the city of Lund, and I thank you all. But also, with us today, we have a very smart lineup of speakers, and they will share their specialist knowledge and add to the possibilities of space-related collaborations. Of course, all this from a Lunda perspective, but also more of a Lunda goes to space perspective.
Yeah.
Well, at least we'll try and reach out further out in Europe. So let us start with what is actually happening in Lund. What resources do we find locally, and what is going on space research-wise? In short, what has Lund to offer?
We can also tell people that we have the speakers with us today, but they're on Zoom, so they're in different places in the world. So they will be joining us later on.
But I also heard that there might be one physical person in.
There might be. If we're in luck, we might see an actual physical person here later on.
Are we physical persons?
You never know.
AI.
So we've got the agenda here as well behind us. And we'll walk you through that one instead of you guys keeping it in sight all the time.
So I think we're going to just start with our first block here. And there we are, speakers, So the first speaker is Magnus Larsson from Max 4. That is not very far from us where we are right now. So, and we all know very much about Max 4. We have all heard of it, and we know it's a state-of-art place, building. I don't know, research hangout to be or something like that. But do we actually know what it is?
It's something strange. Something's very much things are going on there. And,
but what is it good for?
I think better he tells us about it than you and I trying to explain what it is.
Okay, so please make us understand. Beam us up, Magnus.
Hello, my name is Magnus Larsson. I'm head of industrial relations here at Max 4 Laboratory in Lund. And I would like to tell you a little bit about what is Max 4 and how can you use it in your materials research and development. And also give you some practical ideas about how you can get access to the tools we have here at Max 4. So Max 4 is a Swedish research infrastructure, and it's a national synchrotron light source funded by public money. Mostly, but more in general, you can say that it's a collection of advanced X-ray microscopy techniques, or it's a set of different types of analytical materials, analytical research tools, all based on different types of X-ray methods. But more importantly, it's user facility. And what I mean by that is that it's the facility is not here for the scientists working at Max 4, but it's for the open user community of researchers in Sweden, in both academia, industry, and institute. The way it's working is that you as a scientist or a researcher comes to Max 4 with a well-defined experiment and an experimental setup and stay here for a day or a week to perform an experiment. And after that, you return back home to your lab and continue working with your with the data generated here. And our scientists continue by supporting the next user. And When we are fully up and running, we will have more than 2,000 users per year passing through MAX4 laboratory. But today we're already up above 1,000 users per year. We have built the facility in a special way, and that is so we can produce very high brilliant and high brightness X-rays. And we do that by accelerating electrons to close to the speed of light and inserting them into 2 storage rings. And around those storage rings, we force the electrons to let go some of their energy and emit that in the shape of X-rays. And this will lead into different beam lines where you can perform different type of experiments. And by building a facility like this, we can operate all these experimental stations in parallel and work 24/7 to supply these high brilliant X-rays. But MAX4 is not just a synchrotron light source, it's the first 4th generation synchrotron light source in the world, and it's built with a completely new technology developed here in Lund, producing high brilliant and high coherent X-rays. And this is a technology that is now being used around the world to upgrade or build new type of facilities like this. But today we are brightest X-ray synchrotron light source in the world. And how do we use this X-rays? Well, we use it in materials research in various ways. We have different sets of spectroscopic techniques to understand the chemical, electronic, and magnetic properties of materials, such as this Gratzel dye-sensitized solar cell, to understand the chemistry taking place between the dye molecule and the titanium dioxide, and also understanding the electronic structure of the material when light shines on it. We can also looking into other types of materials, trying to understand welding process or the brazing process of aluminium components, and understanding the chemistry at a very detailed level. We also have a set of scattering techniques to understand the structure of material from atomic molecular structure, understanding stress-strain relationship, but also looking at larger molecules such as protein structure determination. The pharmaceutical research is doing here at our facility when they're developing new drugs. We can also look at larger structures and combining tomographic imaging techniques with scattering techniques to understand, for example, like this bone structure or in a wooden fiber, understand the properties of material distributed over a larger scale. With the help of different imaging techniques, such as tomographic imaging, you can look at and get a complete 3D structure in a non-destructive way, understanding, for example, this volcanic mineral, how it's composed of and what is happening during different processing. We can also combine spectroscopy and imaging, looking at the chemical changes over a larger area, like this seed, for example, looking into an individual cell and seeing the different elements distribution. So today we have 16 fully funded beam lines and experimental setups here at MAX4. 10 of them are in user operation, and the other 6 are coming online over the coming 2-3 years. But how do you get access to these tools? So we have 2 different type of access modes, and the main access route is using the peer review access. We have open calls twice per year. You apply for access by describing your experiment, which will be ranked scientifically by an independent panel, and you will get the beam time here for free. And the way you pay back to society is by publishing your results. If you are working at the company or you don't have the possibility to or interest in publishing your results, you can also buy access to the tools by contacting the industry office here at Max4. But either way, the best way to get access is to do so in combination with someone who knows and understands your material system, but also understand some of the techniques here. And here at Max4, we're trying to help you find the right partnership. If it's an academic collaboration partner, someone within the institute, or a private company that can help you with the access to Max4 and the tools available here. But we also like to help you and with understanding and knowing more about the techniques, so you also can use these experimental techniques on your own. But one way we do that is by trying to be connected to different research platforms. And one such platform is the TreeSearch platform, looking into and understanding wood material properties and processes. And they've also invested in a dedicated beamline at Max4 to work with such material structures. Metal Beams is another platform for metallic materials research within both academia and industry, where we're learning more about how to use these techniques and get access to the tools, both here at Max4 and at other similar facilities. And Northern Lights on Food is a similar project for food and packaging materials research. You can also get support through Vinnova funding to try out some of these experiments in collaboration with a research partner, or you can get some EU funding through the Calypso Plus program. And you can learn more about this looking at our website, max4.se/industry, or get in contact with me or my colleague, Selma. So thank you very much, and I'm looking forward to hearing about your material challenges and understanding how we can help you get access to the tools here at Max4.
Thank you, Magnus. I think that that at least gave me some more insights on what actually is possible with the Max4 research facility. And I think the main message was that Max4 is accessible. So please, I encourage you to take contact with Max4 and with Magnus in the future. Do that, please. The second speaker today, thanks again, Magnus. Second speaker today, Per, is he's a star on his own when it comes to the Milky Way excursions.
Very knowledgeable.
Yeah,
yes.
yeah. Well, he's the kind of guy you want to talk to.
Yeah, that's right.
When it comes to outer space there. Yeah, we are very happy to welcome David Hobbs from the observatory here in Lund. And David, he will share with us his stargazer perspective.
Good morning. My name is David Hobbs, and I work at Lund Observatory. Mostly I work on space projects, and I want to tell you a little bit about the kind of space research that we do here in Lund. And you can see from the first diagram the spacecraft called Gaia, which is the mission I work mostly on. This spacecraft is currently 1.5 million kilometers away from the Earth. And it is at a special location. It was launched in 2013, in December of that year, and it was sent on a transfer orbit out to what we call the second Lagrange point. And it's now in a very large orbit around the second Lagrange point, and this orbit is designed to avoid going into the shadow of the moon, which would cause thermal disturbances on the spacecraft. Now, the spacecraft itself is consists of two different fields of view, which basically means two different telescopes. One telescope is pointed in a particular direction, and the other telescope is at an angle of 106.5 degrees away. And we do this because we want to tie measurements of the stars on one side of the sky to measurements of the stars on a different side of the sky. And as Gaia orbits around the Lagrange point, it also rotates 4 times every day. Now, if we look in more detail about how Gaia works, if we take one of these telescopes and we trace out the path over a 4-day period of the telescope, we can see that as it rotates every 6 hours, then it traces out a great circle on the sky. And because at the same time the spin axis of the spacecraft is precessing, here we show the precession of the spin axis over a 4-day period, which gives us a change of 17 degrees. We see that these great circles actually shift along, and this starts to fill up the entire sky. And over longer periods of time, it actually covers the entire sky. And you can see in the top left diagram, we have the sky coverage of Gaia over a period of 5 years. And you can see that the diagram is basically yellow, which corresponds to it making about 700 measurements of each point on the sky over a 5-year period. You can see also there's a red region where this, what we call the scanning law of Gaia, actually overlaps even more, when we get more measurements in certain regions and less measurements in other regions, in the blue, for example. This is not a big problem having more measurements, but it is, of course, important that we have sufficient measurements in every part of the sky. Nevertheless, we have a relatively uniform coverage of the sky. So let's see what Gaia actually does. If we reconstruct the sky, this is what we did for data release 1, which contained 14 months worth of data. Then you can see the galaxy in this galactic plot. Here we have the galactic plane. You can see lots of dust in the galactic plane. And here we have the galactic center, where all of the interesting things go on that we'd like to know more about. But you can see one of the problems with Gaia, which is an optical mission, is that the dust obscures actually some of the most important regions that we're interested in. And I'll come back to that in a few moments. You can also see an artifact of the scanning law shown here. You can see these streaks or lines, and this is because we haven't got enough measurements yet, and we actually see little gaps in the measurements here caused by the scanning law that I just described a few moments ago. You can also see other important features, for example, the Large Magellanic Cloud and the Small Magellanic Cloud, which are not visible from Lund, but are visible from the southern hemisphere. They're important constellations. For example, the Orion Nebula lies over here. This was with 14 months of data and represented our first data release, but we also had a second data release in 2018. And you can see now with 22 months of data, we can see things are vastly improving. You can see that the artifacts of the scanning law are starting to slowly disappear. You can still see the galactic plane very clearly, and it's a much nice picture. This is actually a density plot of the number of stars that we observe. But superimposed on this plot, we've looked at various dwarf galaxies and globular clusters, and we've plotted their motion over the next 10 million years. So, for example, if we look at the Large Magellanic Cloud, which is a dwarf galaxy, and the Small Magellanic Cloud, then we can see that they are actually in orbit around our galaxy. And likewise for the globular clusters, they have various orbits which we can plot out. This is by measuring the two-dimensional motion of the objects on the sky. And also combining any radial velocity data which we have available, which gives the three-dimensional motion of the objects on the sky. And this is a very impressive picture and shows you the power of astrometry. We can really start to determine the dynamics of the galaxy, which is hugely important for understanding how the galaxy is constructed and works. Now, I mentioned the problem with dust a little bit earlier, and you can see in those diagrams that there's a lot of dust in the galactic center. So what I've been working on in the last 3 or 4 years is trying to propose a new space mission, which I call very simply Gaia Near, where Near stands for near infrared. Because if we can look into these dusty regions in near infrared, we can penetrate through the dust and actually see what's behind the dust. And in fact, this is where most of the stars exist. So these are the key regions. So the key regions we're interested in is here, for example, is the Sun. Here's the Orion Nebula. We want to look into these spiral arms, and we want to see in much more detail what's going on. We can only see the brighter stars at the moment in the spiral arms, and we would like to see much more faint objects, and that can be done by near infrared. So we've estimated that Gaia will have a final catalogue of about 2 billion stars, But if we have a Gaia near-infrared mission, we will have a final catalogue of about 10 billion stars. And for the common stars, these 2 billion stars, they will be observed the second time with a very long time gap. And that means that we can calculate their proper motions much more accurately and make much more accurate predictions about the star's motions for those common stars. But we will also get new measurements for about 8 billion new objects. Now, for the common stars, we can also improve their parallax measurements. Parallax gives the distance, essentially, and for Gaia, we have a 20% parallax error out to kind of almost the galactic center, but not quite. And that gives us accurate distances with 20% errors to these large radii. But if we have a 10-year Gaia mission, then we'll be able to extend out even further towards the galactic center. And if we combine the data from the old Gaia mission and the new Gaia Near mission, then we'll be able to extend out accurate distance measurements even beyond the galactic center. This is extremely important and shows the power of the Gaia-type missions. If we compare to the previous mission, Hipparchus, it's this little white circle here, which showed that it was really only sampling a very small volume of the galaxy. Now, this is not the only thing that we're interested in. For example, the next really big mission in ESA is going to be the LISA gravitational wave mission, which is extremely challenging. And that mission will consist of 3 spacecraft formation flying in this triangular-like arrangement. And between each of the spacecraft, there will be laser beams connecting them. And if a gravitational wave passes through our solar system, it will pass through these beams of light and it will cause the distance between the spacecraft to change very slightly. And that will allow us to measure actually gravitational waves. You can see how the constellation will move around with the Earth around the Sun over a period of a nominal mission period of 4 years, but they're hoping actually to extend the mission for a much longer period of time. Now, ground-based gravitational wave detectors have been in the news a lot lately, talking about supermassive black holes coalescing. But the problem with the ground-based detectors is that they have arm lengths of only about 4 kilometers, and they're very sensitive to high frequency events like the inspiral of supermassive black holes. But because LISA has arm lengths of 2.5 million kilometers, then it's sensitive to lower frequency gravitational waves. So it's going to see a lot more things happening. One of the problems is actually it will see everything happening at the same time, because there are many, many objects that are spiraling in towards each other at a slower rate than the ground-based detectors can see. And because of that, LISA will pick up too many signals, actually. So the big numerical challenge that I'm kind of interested in is how to disentangle all of these different signals at the same time, because LISA will see so much. And that's extremely interesting for us. Now at Lund, we're not just interested in these missions. There's also exoplanet missions. 2 examples I will give here. The first is Cheops, which is a small mission from ESA, and it is designed to characterize exoplanets known to be orbiting around nearby bright stars already. And we want to get more detailed measurements of these planetary systems. And this is done as the planets transit in front of their stars, and we use ultra-high precision photometry, in other words, the change in the brightness and colors of the star as these transits occur. And this will give us detailed information. So the goal here is to measure the density of planets that are like super Earth planets or Neptune type planets orbiting around these known bright stars. And here we want to characterize them in more detail for future studies. And people in Lund are interested in this project, of course, and involved in this project. There's also the PLATO mission. The PLATO mission will be launched around 2026, and it will detect terrestrial exoplanets and characterize their properties also. But the interesting thing about this, it will also include planets in the habitable zone of sun-like stars. So basically planetary systems that are very like our own. The mission will provide key information such as the planet radii, the densities, and things like the age estimates of the systems. And this is all needed in order to determine the habitability of these worlds. One of the main questions that PLATO will try to address is how common are worlds like ours, and are they suitable for the development of life? Of course, people in Lund are involved in this also. So I think I'll finish there and look forward to some questions afterwards. Thank you.
Well, thank you, David. Very, very interesting to listen to you, and it's very obvious that international projects such as Gaia has a very strong connection to Lund, and we thank you for that, and we're looking forward to your continued work with the Gaia Nair and so on. And it's also interesting, of course, to hear about that you're exploring if there are other worlds similar to ours. That is something I guess we all want to know more about. But this going on in Lund, I mean, Per, did you know about it?
I was doubly amazed, I would say, partly because of the knowledge that we actually have in Lund. And we started off this in September, October, you and I, the Space Hub Lund, and it's fantastic to see that what's going on here. So that was one of the amazements. And the other one was actually that I understood what he was explaining. So it's interpretable as well. What do we have next?
Well, it seems something. It must be something very small because it's called Nano Lund.
It sounds very small. That's very.
Is it that Nano from the Mark and Mindy? Or
perhaps, yeah.
Well, I think I don't know. But
is it even worth showing? Is it that small? Or?
Well, we'll let Magnus Boyström from Nano Lund give his presentation, and I'm sure it's something big.
Yeah.
Hello, my name is Magnus Boyström, and I'm here in order to talk about Nano Lund, which we consider to be a great place to do nanoscience. And I will give you an introduction, but first I will start with a vision of Nano Lund, which is to be a world-leading research center that uses the unique opportunities offered by nanoscience and nanotechnology to advance fundamental science and to the societal grand challenges. And for that, we have also stated a mission taken and brought up jointly across the department, which is to bring together the most creative scientists, students and industry professionals in an interdisciplinary research environment due to cutting-edge research on the material science. Now I don't see, actually it's removing part of the screen, but I will continue, I'm reading it. Chemistry and safety of design functional nanostructures for energy, optoelectronics and life science applications. Now, let us just present the strategic aims for Nano Lund, and to which we are working right now. That has been our guideline since 2016 to 2020. We are working with highly controlled nanostructures in order to realize, model, and characterize nanostructures, devices, and systems with atom-level control, which from my point of view will also remain for the next 10 years at least. We are working on fundamental science for future devices. We want to discover fundamental physics, material science, and paradigms that may lead to future energy and internet communication technology devices with enhanced performance. Tools for single-cell biomedicine to develop sensors, probes, stimulators, and single-molecule methods for single and few-cell biomedicine. As an example, we are working, for instance, on nanowires with respect to artificial retinas, a project that is slowly moving forward. We want to be a great place to do nanoscience, to be an internationally highly visible nanoscience center that offers exceptional scientific opportunities, training, and career development. And of course, we want to establish an ecosystem that integrates education, research and development, and pilot production to take ideas from research to the marketplace, which will probably be even more pronounced as we are planning to move to Brunnshög, to Science Village, and establish ourselves there within, say, 5 years or so. Let's take a look at the history and the background of Nano Lund. It was initiated in 1988 by Lars Samuelsson, and then it was called the Nanometer Structure Consortium. The nanowires we are mainly focusing on right now, they started to develop in the year 2000, and before that we were looking at zero-dimensional materials in the form of self-assembling quantum dots and thin films, two-dimensional materials. After the nanowires were initiated in about year 2000, it has mainly been nanowires research going on. And we have also created an engineering nanoscience program, which is one of the programs on the LTH. In 2007, it was considered to be one of the 10 strongest research areas in Sweden. We got a very favorable evaluation in the RQ080 called Outstanding. And the Lund Nanolab, which we are currently still using, was built sometime in the year 2007 from a large investment. Since then, we have been having a Linnaeus Center and graduate school. And around 2010, we became a strategic research area funded by the government when Heiner Linke then became the director in about 2013. And we changed the name from Nanometer Structure Consortium to Nano Lund. And now it is a center for nanoscience at the Lund University, involving about 55 research groups in the faculties of engineering, science, and medicine. It's also Sweden's largest research environment for nanoscience and nanotechnology. Now, if we look at how it's organized, in January 2020, we have a board involving the Dean of the Faculty of Engineering, LTH, long other members who are interacting with the management group where Heiner Link is the director. We have input from a scientific advisory board with international experts, starting with Stephen Goodnick, Caroline Hu, Xinchen Kao, Chris Palmström, Henning Grischut, Erik Simentel, and Ulla Vogel. If we go on the right side, we also have an external advisory council with representatives from industry, society, and academia. Interacting with the management group are also the coordinators and the members for the different areas from material science, quantum physics, nanoenergy, nanoelectronics and nanophotonics, nanobiology and neuronanoscience, nanosafety, exploratory nanotechnology, as well as education. And for this meeting, where I can find resources, is the area where I am one of the coordinators, called nanoenergy, where Enrique Barragán in the next session will talk about our nanowires that have shown to be radiation hard for space technology. And the resources we can offer, I think we find them mainly in the Lund Nano Lab, Nano Characterization Labs, as well as the Lund Nano Lab. And what is that? Well, the Lund Nano Lab has about 64 bookable tools, 52,090 booked hours, 2017, with 139 active users, 25 external users. And what are the tools? Well, we deal with synthesis, like metal-organic vapor phase epitaxy, aerotaxy. We have characterization, scanning electron microscopy, ellipsometry, atomic force microscopy, etc. We also fabricate. We have wet chemical etching, processing tools, electron beam lithography, nano-imprint lithography, metal evaporation, reactive ion etching, atomic layer deposition, and so forth. That's what we can do locally in the Lund Nano Lab. And then when we go beyond the Lund Nano Lab, we have the Lund Nano Characterization Labs, which is a large number of medium-scale facilities distributed over about 40 NanoLund labs. And they also contain major facilities such as MAX4, the Lund Laser Center, and Ankram. As an example, we are making time-resolved photoemission electron microscopy, and that would be in the group of Donatas Sigmantas. Our research has also led to about 16 spin-out companies, which are currently in operation. And just for me to mention a few, and you can read the next, Aconier are dealing with sensors. 2C Amps are dealing with nanowire-based amplifiers. We have Glow that are working on nanowire-based light-emitting diodes. Align D, which is a recent company that has formed, and that are actually aligning nanowires that have been peeled off from a substrate or grown by aerotaxy in order to use them for bio applications. And with that, I thank you for your attention.
Well, thank you very much. I must say, this is just piling up. It's so amazing, so much stuff we have here in Lund, and I think it's obviously something that other countries could be part of as well. And I know that there already are, of course, a number of international projects going on, but it seems they could be even more. And Sweden, largest facility for nanoscience, that's something to. And also, I'd like to say the spin-offs in companies, that's very interesting because there is commercial value as well. So all you out there trying to set up a business or something like that, there are many ways, and I encourage you to take contact with Magnus as well. So thank you again. And as Magnus said, we will hear a bit more about Nano Lund in this next section we have here. And to this next section, we also have a guest, a physical guest, Christian Wilke from the city of Lund. But he is a great creator of ideas, and he's making great concepts of them. So we're going to go into one of those concepts a bit on. But first, I just want to say welcome, and also let you understand that Christian is very much involved in building. Magnus did mention Brunnshög, which is a new area. Well, you can tell me more about it.
Yes, it is the whole area around Max ESS and Science Village. So Lund is developing a very large part of the city with very high sustainability goals to support partly the research community and also to make Lund an even better livable place.
Yep.
Yeah. So I have the fortune to be working as an architect planner in a team that's developing that area.
That sounds very interesting, and I'm sure we will make some time to hear more about Brunnshög and the development with the surroundings there, with the research facilities, Nano Lund, and the whole science village and so on. And but that will be a next step. So it's a cliffhanger, okay?
So should we wrap up this first section then? Anders?
Yeah, should we do that?
Yeah. I mean, as I said before, you and I kicked off this Space Hub Lund thing in September, October. And with some kind of a mission to understand, being a part of Future by Lund, to understand what could space bring to the future of Lund. And we started off looking at space material and space technology and space data, and also circular systems that your initiative is going to be looking upon in the next section here. But one of the things that we also realized, that's why we've had these three speeches with us, is that there's a lot of things happening in Lund already today, and we didn't know. We bumped into these and we said, "What?" David Hobbs was doing big thing here, but unfortunately the coronavirus stopped that one. Yeah. So the first question we sort of asked ourselves here as a roundup for this first section is there a value of trying to connect these different initiatives within Lund? And I'd like to start by asking you, Magnus Borgström, are you with us?
Yep.
What are your thoughts on this? What would be the value of connecting the different things that are happening in Lund right now? Is there value?
Well, fundamentally, I think there is always a value in scientists talking to each other where new ideas may emerge simply by discussing, walking into an area that you are not normally in contact with. Pragmatically, to see a connection to Max 4 is very simple because we use Max 4 and we use synchrotron kind of tools in order to evaluate the materials that we are producing, as we are dealing most of all with semiconductors. In the sense of looking at stars, I have to say I'm not really sure what we can do. Maybe we could develop something that, well, we develop solar cells, obviously, and they are light sensitive, but they could definitely not give you any spectral resolution, but they would absorb anything above the band gap. So that would require a major effort of materials development in order to do that. But we are working with materials that easily connect to, say, more applied science as well.
Yeah.
And I think the starting point is really to have a discussion where we find a common ground for discussion.
How about you, Magnus Larsson? We've got a lot of Magnuses with us today. So what about you, Magnus Larsson? What are your thoughts on this? How can we Is there value in connecting the different things that are happening in Lund right now?
Yeah, definitely. And that is the basic principles of how we work here at the industry office of Max4, is trying to make these connections, because we see to get access to the tools, you really need a lot of different set of knowledge groups and know-how. So just by enabling these connections, things starts to happen. And as I presented, we're working with different research sectors or industry sectors like the forest, metal, food and packaging, but we're also very nice to hook up something connected to space. And just by making sure that companies, research groups, and institutes, other actors are connected, things starts to happen. And I mean, we can see just one example here. We have Alfa Laval here connecting to Nano Lund and to Industriell Produktion at LTH. And just a month ago, they had their first common beam time at Max4. And I think these kind of collaborations, they really enabling new things. And if we can set up the similar thing for the space area, I think that would be just great.
Yeah, yeah. So David, the Magnuses, they represent for me some kind of facility that enables people to do research, but you're actually doing this. What's your view on this? Can you see a value of connecting more of the initiatives that are happening around Lund or in Lund?
Yeah, it's not always obvious how we should actually connect together. But for example, I was recently RS meeting here in Lund to bring together space researchers, and I could see that it was postponed, but I could see that a lot of people in geology were actually signing up to it. And it's interesting that, because I've spent a while now developing near-infrared, or trying to get other people to develop near-infrared scanning. Turns out that this is exactly what geologists want. They want to scan the Earth, whereas we want to scan the sky. So there are kind of non-obvious connections between different people, and bringing them together is very useful and interesting to have these kind of interactions. So I was recently contacted by the National University of Australia looking for support letters, actually from geologists who wanted to develop a detector that we use in space for looking downwards instead of upwards. I think there are some good meetings that we can connect through. But it's obvious, though, that the kind of work I do is better coordinated through the Swedish National Space Agency, for example. But they also bring together the other researchers, for example, from geology and so on. So that's a very nice forum to get together.
Yeah. Thank you, David. We lost you partly there, but I think we got the most of what you sent to us. Enrique, do we have you with us as well? Enrique?
Yes.
Yeah.
Hi.
You'll be talking to us later on in the next section, because you also have an initiative around connected to solar cells, and I guess you have a lot of connection with Nanolab then. But have you? And you're really moving forward with this. We're going to hear more from you, so I'm not going to tell everyone the story, but you're really actually taking the next steps around your solar cells. Do you have a feeling that you, based upon what you've heard, the 3 first sessions, is there something there, or where you feel that, yes, I could use this, I need more connections with people within Lund to take my next steps? Or is it sufficient? Has it been great?
Well, I mean, the thing is that this product that I will be talking about in a few minutes, has been developed over the last 10 years within Magnus Borgström's group. And that said, this is a product that benefits from the whole Nano Lund environment that Magnus has described. I don't see the immediate connection now to Max4 facilities, in the sense that, of course, we are also always interested in fundamental research questions, but now we are moving and shifting towards a much more applied product.
Yeah.
And yeah, and with respect to with respect to the Lund Observatory activities, well, we are always happy to hear about different missions and try to figure out how our product would fit into the new demands of the new missions led by scientists in the field.
Okay, thank you. I saw that when I previewed some of your talks, that you have some kind of a connection to the observatory as well, with where you place your solar cells. Yeah, thank you. Okay, I think that was kind of the wrap up I wanted to do.
I think so. Well, and what we are touching on here is exactly what Space Hub Lund is meant to be, a common ground. That's what we are looking for. And from a perspective, let's say a Future by Lund perspective, we always want to connect new players with each other that hasn't been working together prior. And so it's very much about, as both Magnus and Magnus did say, it's about getting a connection and get things started, but not always that obvious, as David did mention. But we have actually had some great meetings between people, and when we did inaugurate Space Hub Lund on the 20th of November last year, we did get inspired by great talks by or from the Swedish National Space Board, from ESA BIC, and the local enterprise T-Kartor and AI Innovation of Sweden. And that was something that afterwards we did have a workshop, and that brought out some 15 different initiatives that we could continue to work on. And so what we want to do is to present some initiatives, some that came out from there, and also some, as we did mention, Enrique will tell us about just in a minute, and that is all focusing on material science and circular systems, and we want to share this, and it's hopefully something that will give you an insight on what is possible, and how can we actually use space technology to create new innovative solutions and building a smart and sane society, and securing a sustainable growth.
Yeah.
So I think let's go to the first second
speaker in the second section.
In the second session. So let's reconnect to Ronald Lund again and material research, and it's Enrique Barragon who was with us right here, and is a very good friend of Space Hub. He's been with us from the start.
A long time.
And it's a very impressive piece of work he's going to show us, and it's not just an initiative, it's in innovation, ready to go live. Yeah. So and it's a very bright solution. So Enrique, please enlighten us.
So hello everyone, I'd like to present our new product that aims to revolutionize the space industry. So in this picture you see here the Earth, and all those red dots corresponds to a single satellite. Just to give some numbers, in 2019 there were around 5,000 satellites orbiting around the planet, which represent an increase of almost 3% compared to the previous year, 2018. And in 2019, the global space economy exceeded $400 billion. As you know, we all use satellite service on a daily basis. For instance, we use GPS or weather forecasting or satellite television. But what you may not know is that most of the satellites are either very close to Earth in a region called LEO orbits, or very far away regions that are, by the way, very much populated with satellites. So how is a satellite orbit designed? Well, it's very customized, but as a rule of thumb, the farther you go away from Earth, the higher the Earth coverage you get, but at the expense of longer transmission times and also a higher total cost of the satellite. However, there's a huge region in between these LEO and GEO orbits, so-called NEO orbits, which are not that much used today because it's pretty hostile to satellites due to the presence of high energy particles that decreases satellites' lifetime. However, this region is kind of a sweet spot between the LEO and the GEO in terms of cost and Earth coverage. So that's the thing, or the main idea of this project is that we came up with a solution that will enable full use of NEO orbits by prolonging the lifetime of one of the key elements that constitute the satellite, namely the solar cell. So here you have a picture of a satellite, and you can see those wings that are quite common seen in those satellites. Those wings are full of solar cells. So these solar cells, what they do is they convert sunlight into electricity, thereby providing power to the satellite. However, satellites, they need to work in a pretty harsh environment, and therefore solar cells are required to be lightweight, efficient, reliable, and most importantly, that they can withstand these high energy particles radiation that I talked about. And the problem is that these particles, they degrade solar cells' performance over time, therefore limiting satellites' lifetime. So we want to make solar cells to last longer. Therefore, we came up with a revolutionary and unique solar cell design where we replace the solar cell material by nanostructures called nanowires. These nanowires are 1,000 times thinner than human hair. And here you can see a picture of one of our prototypes. And if we had a special microscope here, we could see that enables resolution at the nanoscale. We could see those nanowires sticking out on the surface. So in a project here at the university, we observed that these nanowire solar cells are resistant to the high energy particles. They can withstand up to 40 times more radiation than the equivalent space solar cells. This design is better because we only cover 10% of the surface with those nanowires. There's a lot of space in between those nanowires. Therefore, these nanowire-based solar cells, they behave as a hollow structure for a particle radiation. So we think that nanowire solar cells will become a breakthrough for satellite development as new orbits become accessible and lifetime is extended, producing a huge impact on telecommunications, GPS, weather service, and global safety. Therefore, me and my colleagues, Pilar Espinet and Magnus Heilin, we are currently working on further qualification tests for this technology. We're working on protecting our IP, as well as performing a market analysis with the ambition to found a company this year. So I'd like to finish this presentation with 2 more slides, including some specific information that was requested by Anders and Per. So learning and insight so far. We are facing 2 main challenges. We are dealing with a very high-tech product, which is very expensive to develop. And also, we are aiming for the space solar cell market, which is considered to be a niche market, also very traditional. So that means that it's very difficult to enter. On the other hand, we feel very lucky that we are in Lund and in Sweden, and we have at hand a lot of, it's a great ecosystem to develop our product. This product has been developed within Lund University for the last 10 years. And now we are in touch with Value Innovation to help us out to create this company. But during these months, we've been also talking with a lot of organizations and foundations that are willing to support our company. And some of them I list there. So our main goal right now is to get funding as much as possible, of course, and sub-funding if possible. So the idea here is that what we aim is to perform further our research and development activities. We need to get higher efficiencies. We need to upscale our technology, but also at the same time we need to perform a lot of tests and certification particularly for space applications. So we need to perform new radiation experiments. We need to perform reliability tests under ultraviolet light or thermal cycles and so on. And also we need to make a study of the potential market that we are aiming. So that's all from my side. Thank you very much for your attention.
Thank you, Enrique, for elaborating on this. It's of course very interesting to hear that there are so many parts or actors within Lund that could help in this project and has helped and so on. But of course, finding the funding is crucial, and we will get to that a bit in the last section.
Yes.
But one other thing that is also of interest here is that this is something that is built for space. It is a space solution, but it's usable for use on Earth as well as a public value, and hopefully not due to radiation, but for other challenges and needs further on. So that is also something that we would like to elaborate on further, Enrique, at another point. How can we use this on Earth? But again, there is a two-way. Two-way
space and down from
down to
space,
space in this. So and it's very much also about we're talking about before the how to find new businesses, of course, within this area as well. So thank you again, Enrique. But on the 20th of November, on the background of a presentation that was given by Christopher Lasseur from ESA, talking about the project Melissa, which is about the circular system. And a lot more, of course, but we in the later on workshop we did discuss how does one actually define a circular system, and how do we create awareness around what a circular system is and what it is not, and we came up with some ideas, but later on we also hooked up with Christian again, and the thing was that he already had a concept around this and up his sleeve. So it was a very childish concept, but we've been developing it a bit further. But it's it might give you a feel about what it is that we want to try and reach with this initiative. So I say, well, Christian, it's better that you explain about this project.
Do I do it on screen or on?
We can run your presentation.
We'll run your presentation.
Thank you.
We'll do that, and then you can fill in. Thank you.
Hello and welcome to my presentation here. And the question we're asking is if space technology and childcare can create a better tomorrow. My name is Christian Wilke. I'm an architect planner, and currently I'm working with the planning of the Brunnsög Sustainable Development in Northeast Lund. But I've been practicing architecture, planning design in different scales, anything from furniture into urban planning, and in various scales. And also I've been teaching on a few schools of architecture, mainly with working with extreme environments. And this is a program that started in Lund at the School of Architecture in 1999 in cooperation with NASA. So the idea was to bring students to the space environment and NASA, and working with their human factors and closed systems. So extreme sustainability in many ways. So this program is still going on, and it's been a great way of training students for totally new environments and coming up with solutions they would never have thought of on just terrestrial questions. In the space community, it's called life support systems. On Earth, we just take it for granted. And that's one of the great things that I come out with this program and working with the space environment, is that we have to address our sustainability in the same way as you have to do when going to Mars. After that semester for students, we took a lot of them to Africa, to Tanzania for one semester, working with similar questions, but with totally other context and conditions. So it's basically about working with the resources you have. And we found out that the space community can learn from the developing world context, and the opposite. Solutions can be used in both worlds in that way. From these student projects, there's been a lot of really good outputs and a lot of things that have become reality. One of them, orbital systems, is a way of reusing water in real time, and it's turned into a company. And also a lot of solutions have been used in both developing countries and in the space community. And even in 2003, we came out with a book called Towards Mars to Recycle Earth. And in many ways, a lot of those thoughts are very current right now. And then these guys came around, my children, and at the same time, I started working with mainly urban planning. So these are new questions and new issues that took over a lot of my thoughts. And it can come down to this, working with the global goals, United Nations, and the Convention of the Right of the Child. That's a way of mixing these two issues, and that's where I came up with this idea of the kindergarten, or the kinder garden. Because in good urban development, spaces for children are included. And qualitative childcare near your home is in many ways a democratic and inclusive value. And daycare is basically the place where society introduces itself for a child. So let's make the place for that meeting positive and sustainable. And when planning cities, the need for daycare facilities is very difficult because demographics vary and it's a very long building process. So when you find out the need for a daycare facility, it can take up to 5 years before it's there, and then there might not be children in that area. So you have to look at flexible solutions. So to ensure daycare where it's needed and when it's needed, flexible and agile concepts has a great value. And this is one of many solutions. So this is not the only one solution for daycare, but one of many. Because this is what is offered right now, standard temporary units. And the location of these is based pretty much on where there is technical infrastructure, where there are pipes, where there are electricity, where there are sewage. That's where you can locate them. Like this one on a parking lot in the back of a school. And of course, there's often a lack of architectural values, both inside, outside, and to its context. So there's very little connection to the pedagogical ideas, and very few sustainable solutions are offered right now. And they are temporary, but they often stay for a long time, and it's heavy investment. They are quite expensive. And here are some inspiring existing innovative solutions. Outdoor education in parks using a very small space, or a bus daycare unit where everything is fitted in a mobile bus going out in nature with 16 children aboard. So is it possible to create a qualitative yet mobile off-grid daycare building with minimal impact to support the users? And is it possible to make the self-sustainable building and its design into a generator of sustainable systems and behavior? And can these ideas and visions be canalized in one tangible object, focusing on the local context, and then upscale for global use? So this is the idea of having a building in an open phase for use. It opens up and uses and utilizes the space around itself. And that can be a park, and it can be a green area just outside the city. And when it's closed, the building is transformed into a closed volume that can be used by anyone all the way up to the walls. And it has to be safe for any kind of fire or graffiti, but then it's taking minimal space. And when the function is changed, it can be just removed and the park is back to being park. So this is the vision of that building. And there's a lot of things that has to be developed. And I think that's one of the values of looking at how can rainwater be harvested? How can the off-grid systems be developed? And this could be a clean test bed where only the best solutions can be used. So, and also if you have a new kind of compact building like this, you can choose all materials. So this can be a no-tox building where all materials are tested. And of course, you have to look at new energy solutions, and you have to look at new ways of creating and eating food, and Also, only 3% of the staff on daycare units in Sweden are male, and this could be a way of introducing another way of working at childcare units, attracting also men. So, of course, but from my point, I think to make it into a good place, a good space, inside and outside. And to prove that sustainable can be comfortable. There is no conflict between sustainable and having a good life. And the importance of human-oriented architecture. And that off-grid really enables real flexibility. And here, the value of a tangible example. This is not going to be a report. This has to be a building. That's why I think it's very important. And to continue prototyping, testing, develop, and a test bed and integration of existing sustainable solutions that can be even better working together. And of course, to inspire, educate, and communicate. Thank you for listening.
Thank you, Christian. That was very enlightening. The thing is that there was a very hopeful presentation you gave here, a human approach. You're combining a lot of things, life support systems, sustainability, and sustainability versus a good life. I mean, sustainability, isn't that the grounds for a good life? Or?
Of course it is, but sometimes, I mean, it's about sort of, spending more is not always making things better. It's about spending it right, and that goes to resources and time.
Yeah. But you're also touching on a number of other things we've been discussing here. We're talking material, of course, and there is a lot of connections to other space research areas. It's not just, well, one could say a circular system contains them all, or?
Yes, I mean, of course, the circular system is optimizing, but I think the important thing here is to sort of have an architectural approach to make the livability as part of the functionality. Because if it just works, then you're kind of missing the point.
Yeah.
And I think that the thing is that this initiative here is something that we have found out that we want to try this. We want to go further with it, and there actually is a small group within the Space Hub Lund community, sort of, and we are working on trying to get a pre-project within the with a European Regional Development Fund to actually start working with this now. So it's not just an idea; it's much more of an idea, and I think you saw that as well with the Christian's pictures here. So thank you very much.
Thank you.
On the 20th of November, we also back to material. I can say we were joined by Alfa Laval and Magnus Nilsson, and they are, Alfa Laval is a great connection to Lund, of course, the company in itself, but they are being a top developer and supplier of heat exchangers, and of course they were curious about what space material research could do with and add to their own R&D. So we've invited Magnus Nilsson, who is head of the R&D at Alfa Laval here in Lund, and wanted to mention a bit about how their work is going on and the connection to the space industry, what they might be gaining from that, and what's going on there. So, Magnus Nilsson, please heat it up.
I'm Magnus Nilsson. I'm working for Alfa Laval. When I first visited this session here with Space Hub in Lund this autumn, so I was some interest in how space has been working with material, and also to that extent that it would have some good purpose for us in Alfa Laval. So I would like to come to that, but first I would like to have a very quick introduction to what Alfa Laval, what we are, so everyone are aware of the company. We base our company on three different technologies. The first one we call heat transfer, and that consists of many different type of heat exchangers, both plate heat exchangers and tubes. And then we have something that we call a separation technology, where we work with high-speed separators and also decanters. And then finally, our third leg is what we call fluid handling, mostly pumps and valves for hygienic use, but also pumps for specific marine use. And as you can see, our organization is divided into 3 different divisions: Energy Division, Food and Water Division, and the Marine Division. We serve most industries, I would say. So we are not into one specific application or one specific area. We're into many different types of applications and here you can see some of them, just to show the wide area of use when it comes to all our different products. Shortly, the size of the company, we are around 17,000 employees. We have an order intake of 5 billion euros or 4 billion euros during 2019. And as you can see also on the result, we are a rather healthy company when it comes to 2019 at least. This was very, very short about the company for everyone to understand what Alfa Laval is. And then back to my challenge as I see it. We produce most of our products in steel, and especially for plate heat exchanger, they consist of stainless steel or titanium, and then the blue part you can see here where the pressure retaining carbon steel frames, so to speak. And my challenge here was to see, okay, what is done in the material area when it comes to new development there? Could we, for example, develop a new material, metallic or non-metallic, with twice the conductivity and half the weight compared to stainless steel? What about thin material? We are talking about 0.5 or even thinner, and then have a double strength and still remain the weight. Is that something? And also, I mean, when we press this stainless steel or titanium plates, the formability of that, could something be done there? Could we keep the formability or maybe even have it better than what we have today in stainless steel? Of course, this is some type of wish list that could be interesting to see what has been done or what could be done. And also then to consider, I mean, we use the material, as you have seen, for many different types of industry. One of them is hygienic application. When it comes to heat exchanger, it's a pressure vessel. We need to fulfill that with a new material. And also it must be able to produce in very high volumes. And then, of course, finally, to have global access to the material. Again, this is a wish list, but still it's interesting to see what has been done in the research on space level, so to speak. So with that said, it could be interesting to get a deeper insight in how and what of type of material research that has been done in connection with the previous slide. And also, are there any ongoing initiatives that we have at the moment? And finally, I mean, are there any similar cooperation with other companies in the material area in the space business? I think that was very short the idea I had when we met the first time, and that Alfa Laval is looking for. Thank you.
Thank you, Magnus. As a very, I mean, it's a very direct need and a question. This is something that they are working with, and so this also another question this poses is, how do we actually do this? How do we gain from each other? How do we share this knowledge? And what are the possibilities of let's say for companies to work with the space industry that not already are involved with the space industry to take advantages of what's happened there? And yeah.
Yeah, I'd say that one of the core things that we try to look into within the Space Hub Lund initiative as such, is how to capture initiatives, and we have we have seen that some of the initiatives are already in Lund, but we need to identify them and capture them so that we can find out how we can support them. But also then encourage initiatives. So you were saying on the 20th of November that we had 15 initiatives that popped up. I'd like to say that ideas are relatively easy to come with, but it's very hard to actually move the ideas into realized value.
Yeah, it's true.
And that's, I think that would be one of the core things within Space Hub Lund that we really want to find ways of doing. So that's one of the core questions we try to answer for ourselves and towards you guys as well that have these initiatives. What kind of support do you think you would need if you look? And I realize you've been around for a while. I think some earlier slide I saw you were really up with NASA as well, trying to get them encouraged. So what would you say? What would you need? What kind of support would you need to move this forward?
Well, I think the most important with this project is that it happens, and I mean it's a product, it's a platform and a process. That's how I see the project, and it's not going to be the perfect product from day one. I think the versions and sort of the goal is quite set. I mean, if you say you just make sustainable solutions, that works. But to actually go off grid, it sort of really is a tangible goal, which is either you do it or you don't.
Yeah.
So I think that's where it can really sort of inspire the solutions to spin in to this project and then spin off again. I mean, you don't almost go to Mars. I mean, this is either it works or it doesn't work. So and of course it's a triple helix issue, and I think the municipality are the buyers of this service, and the universities, organizations, or institutes needs to sort of collect and develop the solutions, but then it needs to be some kind of the vehicle owner or the producer of the service or product is sort of the most important step, because the municipality cannot develop it by itself, and the university cannot maybe produce this complex product. So I think it's really a triple helix issue. And somebody asked me if this was sort of a Tesla of daycare, and in one way, I mean, it's like I'm not an Elon Musk, really not. But this needs some musketeers. I mean, it needs a lot of different drawers and so I think. But to start with the small version is probably the most important. The tangible object.
A small pilot as well. But I know you can't answer for Enrique and Magnus, of course. But even if you do find out that there are possibilities, is there an obstacle for you maybe to use them? We can point this question to Magnus or Enrique as well. I mean, even in the situation, Magnus, that you are in this large international company, if you were given possibilities, I mean, can you actually use them? Let's say from support from ESA or something. I'm not saying that you're going to get that, but if you did.
Magnus Nilsson.
Magnus Nilsson, please.
Support, I mean...
Or knowledge.
When we met first time, I mean, it was more a general question on material, and then what is happening in the research area, and so the support we would like to see, or is there really this type of development or research ongoing, and then of course we could benefit from that and also contribute in from our point of supporting that. Definitely we can, but as I said in the beginning, it was more a general question and say, okay, are there any research in that material area which could be beneficial for Alfa Laval, and in that case, what is happening? And it was mentioned in the beginning here that in Max 4 that Alfa Laval was participating and doing some tests. Yes, we are, but that's mainly tests that are based on material that we have developed to more deeper understand the behavior of that material. It could be interesting to see it the other way and say, okay, here we have a material that maybe could be beneficial for Alfa Laval, and that's where my interests come in and see what has been done. Could we maybe give more of our demands or our wishes into something, and then see how could we take that further.
And Ulrike Bohlman from ESA, I think you're sitting in a cottage in France somewhere, aren't you?
Yes, I am. Yes, I am.
Yeah. When you listen to these three initiatives and based upon your experience, what would you say that we would need to support them with to get them moving along into some kind of realized value? Have you got any experience on that?
Well, I think the most important thing would be really to establish the connections. And I think that is what you are very much doing at Space Hub Lund, to just bring together what is happening on the different sites, because what these initiatives need are like the customer or the network that maybe someone can provide. Like at ESA we have, and I will talk about it later in my presentation, we have that network that is called the ESA Labs. So maybe that is something that also these initiatives could look into together with the Swedish National Space Agency. This is one point, and there are other ways to connect also to what is going on at ESA. So I think the most important thing that you need at this point is really tap into the resources, into the networks, and make the connections.
Yeah. You mentioned the Swedish Dreamstyrelsen and the Swedish National Space Agency. Tobias, you're with us as well. From a Swedish perspective and your experience, what would you say that we would need to support our initiatives with here in Space Hub Lund to support them on moving forward?
I think that you have really good opportunities. I mean, you have all these highly advanced facilities and good research, and you're also in this dynamic region, even if it's maybe a little bit restricted with bridge crossings nowadays. But I think that you should continue with this kind of facilitating and get different people to meet. I think it's interesting what David Hobbs said about meeting the geologists and seeing that we have common interests in this. So I think it's a lot about connecting people, getting the ideas flowing, and then of course to take care of the ideas and make something happen with them. It's much easier to get an idea than to go all the way through to have something that's actually commercial and viable. And I think with this having this space hub, and if you might get an ESA BIC, for example, to Lund, I think that would help us well in a good way.
Yeah, yeah. I think perhaps that is one of the main issues here, actually connecting people, and because the ideas are so diverse.
Yes, it is. Yeah.
And the need for support is very diverse. But I guess we need to have some kind of a connection hub, so into these different areas, so we can.
Yes,
so you can.
And also, as David said at times, not just looking up, look down as well. Around in geology or so. So we're actually stepping into the third and last session here.
Yeah. With
these questions, and that's Lund in the world and the world in Lund. So how do we do this? Yes, the collaboration, and both Tobias and Ola have already mentioned a few things, but they will give some short presentations on this as well. And there is, of course, a lot of different programs running with the objectives of securing promising projects and so on, and tangible results. But there are huge knowledge resources out there, but as well, hopefully there is some money too. So Ulla, in your French cottage, could you please? You did mention the ESA lab, and that is something that you will give us a bit more of an insight of in your presentation now. So, Ulla Bullman, I say Ulla because we are very friendly with each other, but Ulrike Bullman, please
run the presentation. Yeah.
Run the presentation.
Good morning from the French countryside. I am very happy that Future by Lund made it possible for me to join you under even these funny circumstances in a remote way. My name is Ulla Bullman. I work for the European Space Agency in the Director General Services for Member States Relations and Partnerships. And I will give you a short introduction to the ESA Lab concept. So what does it mean? Where does it come from? It is an initiative that was launched by our Director General right after the Council meeting at ministerial level in Switzerland in December 2016. It is based on the ideas of the resolution towards Space 4.0 for United Space in Europe. So you have all the ideas already connected: Space 4.0, United Space, and Europe. So, what is it in detail? Well, the concept is based on the image of a neural network. And this neural network is designed to support ESA's mandate. That is to support cooperation in Europe in space research and technology and in their applications. So what we strive for is interconnected intelligence. And we do that by creating an institutional link between academia, research organizations, industry, and the agency. All this on a non-exchange of funds basis and with the aim to intensify research, development, and outreach. So it's pretty much the creation of a hub for disruptive innovation and for cross-fertilization. So it's actually quite parallel to what the idea behind Future by Lund is. So what are the working principles? Well, each ESA Lab is a joint initiative which functions according to the following general principles. It is bottom-up driven. That is, you bring your ideas and we connect you to the right person in ESA to take it further. Each participant puts its unique strength into the action so we can leverage what is unique to you and connect it to our potential as a space agency. The idea is then to reach out and multiply by going off the beaten track and to bring fresh ideas connecting space and non-space. So here are some examples of what we have actually done. So the first ESA Lab is the blue one that was established with Switzerland. It's called Igluna. And it brings together 16 teams of students from 11 universities. And what do? They develop technologies with the purpose to demonstrate these technologies for space habitat. And the idea of that space habitat is obviously to sustain life in a harsh environment. And they also operate novel technologies through a remote control system. And they had their field campaign organized in Swiss glacier. So that was the first one. But as you see, all these ESA labs are spread around Europe. And they have a broad range. You see, we go from a moon habitat to artificial intelligence and quantum computing, to exploration, space medicine, but also to such down-to-earth subjects as economy. So it's really, really broad. So what can you expect from ESA? Let me repeat, it is not a funding mechanism, but what can we actually contribute? So the potential support by ESA for the specific ESA Lab includes our expertise at different milestones throughout the project, access to our infrastructure and our brains, open data, the institutional link that is created between you and ESA, support for the communication and outreach activities, and also access to other ESA programs and initiatives, like, for example, the education program, the ESA BIX, the General Support Technology Program, the Open Space Innovation Platform, etc. So this all makes you part of a bigger network, and that is really, I think, the main point where you can benefit from it. So practically, how does it work? Well, the ESA Lab is established through a memorandum of collaboration, which is a non-binding agreement between academia or the research institutions and ESA. It is open for other parties to join, so that could also include other parts of academia in Sweden or even outside. It is signed between the head of the institutions, of the president or the dean if it's a university, and our director general. And there will be a steering committee to guide the activities of the lab. So a steering committee composed of people, both of the partner and of ESA. So as you see, the implementation as such is really, really easy and flexible, and the leadership is shared. So for more information, you can visit our website, or you can get in touch with me, and I'm looking forward to your ideas and to your initiatives. Thank you.
Thank you, Ulrike, and thank you for encouraging us to take part of all these initiatives that you actually do have within ESA. And of course, that we when we started up, we did not know about anything, but now we're starting to learn more and more about what's actually there. And so some of these possibilities they go through you, and some of those maybe on a closer level with the Swedish National Space Agency and so on. And Tobias will talk about that as well. But again, it's amazing to hear. I will stress what you did say, Ulla. It's not a funding mechanism, but it's an access to knowledge, data, and programs, and the ESA network, not least. So, I hope that we can define some areas where this could be a usable program for us, and also maybe it's something. Well, that's rather a question. Is that something? Are there any ESA lab set up projects running right now that are cross-border? For example, if I wanted to do something with the Danish Technical University, could that work, Ulla?
Yes, that is totally possible. There are already, if you look, for example, at the Swiss example, they invite also other universities from outside Switzerland. It's totally possible to also invite contributions from other partners that are not from your country. The thing is, however, that as an international organization, we are governed by the governments of our member states, and that means that we also need to include in the process of setting up such a lab, we need to include the approval somehow of the national delegation. Yeah. So in your case, that would be that the Swedish National Space Agency is actually agreeing with the principle. That is then up to discussion with them. There are member states where that is fairly strict. So we have one member state who said already we want to control everything that is going on. We had another member state who said we are fine with just everything that a university proposes to you. So that needs then to be discussed with the national delegation.
Yeah. Thank you. It's a bit hard to hear sometimes.
Yeah. Well, a bit hard. We lost you there
due to the connection. Yeah.
Yeah, but that's not your problem. But we will. I'd say that it would be very interesting to see what we actually could do here regarding an ESA lab, and I'd like to continue those discussions with our parties within the academy further on in research lab. On our way to establishing this, or on the way to establishing European collaborations, it's very important for us to secure that we are aligned with the national strategy and focus, of course. And our guide here has been the Swedish National Space Agency. And thank you very much to Tobias and Björn, who has helped us a lot there. I should say that they are our foremost partner in creating this Space Hub Lund initiative. Some of us had already been sort of baptized by Tobias Edman, one of the agency's most dedicated preachers, and not least on space data. But as a repetition is the mother of learning.
Yeah.
Tobias is the head of innovation and public benefit, and we always learn something new from him. So Tobias, please take it away.
Hi, my name is Tobias Edman, and I work at the Swedish National Space Agency. I'm head of innovation and public benefit. And I will talk about strategic networks and financing within the space industry today. First, about Swedish Space Agency. We are the national and governmental body for space affairs in Sweden, and we work with the spread of knowledge about space and its benefits, and we support national space research and development. And we also represent Sweden in international space organizations. We were established in 1972, and we are 21 employees, and we have a budget of about 100 million euros annually. If we start with the strategic networks, this is the Swedish space ecosystem. More or less, I guess it should be some companies included as well. So if you feel that you should be here and you're not, then just contact me. And it's roughly 60 companies represented here, and working with a huge part of what is space and the space sector is from rocket engines and launchers to data exploitation, communication, and different kinds of instruments and ground services. And then we have the European Space Agency, ESA. This is where most of the money from the Swedish Space Agency are spent. And it's an intergovernmental organization with a huge representation of European countries, as well as Canada, that are involved in the European Space Agency as well. It's 22 member states and established 1975, and each member state has a vote. And there is a lot of different kind of programs and projects, and you can vote in the programs where the country is involved. The European Space Agency is based on the contribution from the member countries, and the contribution goes back to the country. So Swedish space sector, they have not guaranteed, but they compete about the money that Sweden has put into the cooperation. And the ESA budget is roughly around 7 billion euros per year. So it's a huge budget, and the Swedish part is not that big, as you can understand. And it's based on mandatory programs where all countries are involved, and then on optional programs where you focus on what each specific country thinks interesting, and also where the industry from the country can contribute. And per domain, if you look at the budget, it's navigation, space transportation, which is launchers and rockets, and then Earth observation, which are the biggest part, and that's mostly what space actually is about. And then it's telecommunications, which could be seen as, which is a really important part of space, but that is to a large extent commercial, and much of the development is made on commercial basis. And then, of course, there's scientific programs that are different kind of startup activities and innovation and development programs as well. And from a Swedish perspective, we put in 1.7% of the ESA budget, and it's 83 million euros per year, roughly. And if you want to do business with ESA, I mean, as you've seen, it's kind of a lot of money involved with that, and there are different kind of interesting programs. There are, you should go into, it's called EMITS. I will talk a little bit more about it later. But there's mandatory programs and there are optional programs. And the optional programs, that is where Sweden think that we can contribute and things that we think is interesting. And there's also support for technology development to make different kind of spin-ins of not space technology into space and space technology out of space, which is spin out. And of course, we shouldn't forget about the sustainable development goals, which is really important for space business. We believe that space is an important part to solve all of the goals. And that's also something to think about when you come up with your business ideas. And then we have ESA as a customer and financer. And that will be based on the idea you have. You have the ESA business applications, which is where you can take your idea into business. So it's kind of a startup innovation support. And then you have to send a ESA tender proposal and also contact the Swedish Space Agency, as it's actually our part of the budget that's used. You need to have a discussion with us as well so that we can promote the idea. And then it's Horizon Europe, which is the EU money. And that's a lot of, it's billions of euros. And some are put aside for space components. And there will be a new program, Horizon Europe, with a launch in 2021. So if you have good ideas and you have some backup money, this is also a way to really boost the financing. And the ESA Business Incubation Center in Sweden, which is funded by the Space Agency, ESA, and the Swedish Innovation Agency, Vinnova. And that's a 2-year incubation with 50,000 euro in company funding, and it's established in Luleå, Uppsala, Trollhättan, and hopefully soon in Lund as well. And this is the main way in for funding if you have a startup idea and a space-related business idea in Sweden. And then there's additional Swedish funding from Vinnova, the Innovation Agency, and from the Research Council for Sustainable Development, Formas. And of course, you could also have some others like Energimyndigheten or Tillväxtverket, but mainly most of the innovation money will be Vinnova or Formas. And then we have a program or a project, the National Space Data Lab, together with AI Innovation of Sweden. This is the place if you're working with space data and space data exploration, then it's you have the opportunity to co-work within the National Space Data Lab and to get contacts and within the AI community of Sweden to see how to develop your ideas and your algorithms. And then, of course, there are other investors. If you have a really great idea and you can show that you have this commercialization, then there are venture capitalists. There is a space fund, for example, for Europe, and then there are a lot of different investors that you could approach. And that's where you get help. If you are, for example, in the business incubator, you could get help to see which kind of venture capitalist you should contact with your business idea. And that's all for now from the Swedish National Space Agency. And if you have any questions, please contact me. Thanks.
Thank you, Tobias, and thank you again for having you. It's very obvious that there are ways for funding.
Yeah.
And I just want, I'm not going to write the applications for you, but if you do have any ideas, please do not hesitate in contacting us, and we can guide you at least in the right way. So yeah, there is a lot of good opportunities, isn't there?
Yeah, what we've been trying to show now is really to start off with in the first section. We want to show that even if it's new for us to get into this, it isn't new for Lund, because there's a lot of things already happening in Lund. So we try to lift that one up. But we also want to give you some examples of the initiatives that are very exciting, that are happening right now in the section 2 that we had. We really need to get our heads around how do we support these initiatives so we can move them into realized value. And in this third section, what we try to show is that we need to interconnect globally. I mean, so that we get into. And I do respect that when we started to plan this, when I was talking to Magnus Borgström, Larsson, and also David Hobbs, each one of you actually explained for me individually that yes, we are already a global pair, so this is nothing new for us. We are already acting in a global manner. But one thing that actually struck me now when I'm sitting here on the sofa is that we are trying to combine the entrepreneur in a way, or intrapreneur in Alfa Laval, or a societal entrepreneur with the preschool, with that kind of thinking, where you have a personality that perhaps wants to build something and wants it to happen now, with a lot of research, labs, and when we listen from ESA, for example, it's a lot of laboratories, and there's a lot of, even David is research based, or the facilities are research based. So I'd like to ask you, Tobias, that question. Do you have any experience of how to handle sort of this meeting from the entrepreneurial point of view? I understand in your presentation that there is money, there's funding, yes, but how do we sort of create a meeting between the entrepreneurial drive and perhaps a more slower pace of the research drive? Have you got any experience from that?
No, not really. Actually, I think that what you are doing are really inspiring. I think this is a good way. We have not been working with this kind of forum in that way. Actually, in Sweden there are the Space Forum, or Rymd Forum in Swedish, and I mean they are working with meetings, but that's mostly within the space community. So I think what you are doing right now, actually having this series of meetings where you invite kind of broadly to those who are interesting, I think that's a really good platform to do this. So I think that you are the ones that are inspiring, and that should inspire us.
We didn't pay you for saying that.
No, I can't remember planting that question.
No.
No,
it's okay.
Thank you.
Thank you. I know, Ulrike, we have a bit of a sound problem, but I want to try to ask you anyway, see if you can answer close to the mic perhaps. But do you have any experience of this? Do you understand what I'm trying to get at here? How do we sort of get the entrepreneurial drive and meet the researcher and find a good connection in between the both?
Yes, I hope it works better now. You hear me?
Yeah.
Yeah. Well, I would like to echo a little bit what was just said. It is really a very good initiative how you set it up. We from ESA, for us, it is very easy to meet with the space community, to talk to those who are already converted, baptized by the waters of space. What we like to benefit from is really that kind of outreach that you are organizing. So to go to the research facilities, to go to the universities, and to go also to industry that is not yet space industry. That is where also we get fresh ideas from, and it's very beneficial to connect all those. So I can only congratulate you on your initiative, and I hope that we can get something out from there, something very specific for the region around Lund. So I heard that also for the ESA Big, there was there is the idea to expand and to get another center in Lund. So that is a very good step for entrepreneurs, and if we can also establish that for the research community, that is very beneficial.
Yeah, thank you. Thank you, Ulrike.
We can just add to that, and thank you, Ulrika, as well, that we were supposed to have Jens from the ESABIC Sweden North with us today, but he could not manage, and hopefully that is due to his working on support letters and the coming application for the next 2 ESABIC years, where hopefully Lund, as a few of us have said now, will be included as well.
Yeah. And I guess that's what we're looking for in the next step as well, isn't it, Anders? To get people with that are sitting with ideas today, after perhaps viewing these different speakers and hopefully got inspired. Yeah. Either they have an idea that they want to come forward with to contact you or me, but also if they're already working on something. And we can support them in getting connected somehow.
Yeah. And I also think that there were some people, when we started out talking about space, I mean, this is way back when Per Persson in Lund took the initiative to look into the space area. There was a number of companies we were talking together within the business council, and a lot of them said, well, no, we don't have anything to do with space. But today they are, some of them at least, are very willing to talk about space. And I think that that should be one of your main reasons to connect with us. If you feel that you're not doing anything with space, contact us and we set up something with space, because there are so many interconnections now, and not least when we were talking about space data and so on, and how connectivity, talking about future mobile solutions and traffic solutions and so on. So there's a lot of more connections, and we also see that there is a lot of connections to the strategic and infrastructure projects that are running within the municipality, and well, there is a lot more to gain. So please get in contact with us, and we'll bring your ideas further in some way, or yeah.
Yeah, and our next session is June 4th.
June 4th. Yes.
And most probably in some kind of session similar to this.
Yeah,
one.
we don't have a concept, we don't have the format yet, but
we need to be flexible all the time. So we're prepared for everything.
Yes, but we are not postponing. 4th of June it is.
Yes.
So you're welcome back again, and I was almost saying hopefully it's going to be even shorter next time, but yeah.
Most probably about how we network.
Yeah, it is, but
very tangibly in a good sense.
Yeah, in an effective way, even though we can't really meet physically right now. But that's a good thing as well, at some point. And we are trying to of course tighten up the format as we are meeting like this. And there was actually one. I think we are not up to 3 hours now, are we? As we said from the beginning now. I did visit another webinar yesterday, and they said it would take 2 hours, and it was only 45 minutes, and I was so happy afterwards. So that was a joy in these days.
And this one is recorded, so if you want to recommend it to somebody else, you can do it, and it will be on the same page that it's viewed on right now. Yeah. Or the Facebook, Future by Lund.
Yeah, so Future by Lund /Space Hub.
Yeah. Okay.
Excellent.
So is it a wrap, Anders?
It's a wrap, and I'd like to say thank you to all of you, our guest speakers, and for your effort again. And I'm really grateful. And thank you, Per, for helping us all in getting this in the right way.
Thank you. Thank you all.
Thank you. Yeah. And thanks for the team behind
the film cameras and the sound. Yeah.
Everyone, thank you. And have a great day further on, and stay healthy and stay sane. Sei gesund.